Hello everyone, let's do our week 10 pre-recitation. We're going to focus on the calculation, or doing light calculations, my favorite kind. So I'm going to go through part 1, and part 2 I'm going to leave for another time, because we have a very short amount of time to go through this. So the first question is, calculate the wavelength in nanometers for the following transition. N goes from 3 to 1. And what you can see up here is I have two types of equations. I call this the Bohr equation and this the Rydberg equation. I think they have different names depending on who you're talking to. But the most important thing is you can figure out which one you want to use based on what the question is asking for. So if this question is asking for the wavelength, you should probably use this equation because it has wavelength built into it and it reduces the amount of steps you have to do. And as I always say, the less steps you have to do, the less chances of you making an error along the way. So we have an n equals 3 to 1 transition. And when you're using this equation, I have written this exactly how you're going to see it on an exam, where they will tell you 1 and 2. They will not tell you anything else about these. I'm here to tell you that in this equation, this is always the lowest number, or the lower number, and this is always the higher number. So what you can do is, 1 is over lambda, 9, 6, 6, 7, times 10 to the 7, times 1 over 1 minus 1 over 3 squared. And we'll put the squared in there, which we know is 1 over 9. So what we can actually do is erase this and just put in 8/9. 1 minus 1/9 is 8/9. This will just make solving the problem a little bit more expedient. So we run through this, and what we will find is 1 over lambda is equal to 9.75 times 10 to the 6 inverse meters. This makes no sense. Inverse meters is not a real thing. So in your calculator, what you can do is you can either do 1 divided by the answer, or you can raise it to the -1 power. Either way, you will get lambda is equal to 1.03 times 10 to the -7 meters. Question wants it in nanometers, so we now multiply 10 to the 9 nanometers for every 1 meter. Whoa. Meters cancel. And we end up with 103 nanometers. And for the sake of completion, and because I think it's fun, this is the UV region. Generally, if you want to think about what is the visible region, it's 400 to 700. Anything lower than that or smaller than that will be higher energy, and ultraviolet or X-ray or beyond. And anything higher than that, say 1,000 nanometers, is going to be lower energy, and the infrared. So that's one problem. Let's do the next one, and then we'll move on to the recitation. So I'm going to erase this guy. But I'll leave our equations up because it's handy. All right, it says to calculate the final n level for the following transition. We know it starts at 2, and it absorbs 4.58 times 10 to the -19 kilojoules. So we have to use this one. They tell us an energy, and they tell us our initial energy level. So we put in 4.58 times 10 to the -19? Yeah, 19 joules. And that's equal to -2.18 times 10 to the -18 joules times 1 over, and now here's the other thing. Where do we put this 2? So this was low and high, but this is final minus initial. We don't know what the final energy is. Or I'm sorry, we don't know what the final energy level is. We know what the final I'm sorry, we know what the initial energy level is. So in the final, we put our x, and that's squared, minus 1 over, and our initial energy level was 2. So for the sake of completion, we'll put the 2 squared here. You and I both know it's negative 1/4, but we'll keep it light for now. So now we divide through by negative 2.18, and we end up with negative 0.210. It's unitless, the joules will cancel, is equal to 1 over x squared minus 1/4. All right, so let's add 1/4 to both sides. We end up with 0.0399 is equal to 1 over x squared. Think about what I just said. You have to, one of the steps you'll have to do is take the inverse of this. So either do 1 divided by this value or take the negative 1 power of it. You will end up with about 25 is equal to x squared, square root both sides, x is equal to 5. So what this question is saying is it absorbed this much energy, it started at an n level of 2, and it ended at an n level of 5. All right, let's go on to the actual recitation. I'm going to skip over the lengthy discussion on light and chemistry, and I think it's more important that we dive into periodic trends and chemical bonds.